All right, so let's talk about what's new with Mastercam Lathe and Millturn in 2022. So we'll start with Millturn, and this also is included for Lathe. So the biggest thing I think this year, what's new with Millturn and Lathe, is they now give you a generic list of machines that come with an installation of Mastercam. So if you guys have Mastercam 2022 installed, you now have all of these machines available at your disposal. And so there's 5 Millturn machines here that you can use if you have a Millturn license. And I think what's more significant than that is these top 3 machines are simple machines that only require a seat of lathe and mill to run. So when I say simple machines, it's a machine that doesn't maybe not have dual turret. It only has a single turret, could have either single or dual spindle. So the nice thing about those machines is they're just like Millturn. It has full machine simulation. You can load up your 3D tools for the most accurate simulation you can get. It has steady rest simulated, so on and so forth. So it has all the bells and whistles of Millturn. So if you currently don't have the Millturn package, you just have Lathe, these 3 will be a good introduction into the Millturn package. If you do have Millturn, we have these 5 generic FANUC Millturn machines available that you guys can use if you have a license of Millturn. And once again, those all come free installed with 2022 as long as you're on an active maintenance contract. A couple little small things here that I think are actually pretty big. The Subprogram checkbox. Previously, some Millturn machines did not have the ability to use subprograms. Now in 2022, everyone should see this option available to them. So previously, this was either not shown or grayed out in Millturn, the option for subprograms. You now can output subprograms. If you go back to your shop and you go to run your machine and it still doesn't have this option, let me know. I might just have to send you the latest machine file that does have this option. Incremental spindle moves. So, if let's say we wheel our sub spindle over to grab onto our part that's in our main spindle. So let's say we wheel the sub spindle over 48 inches, I grab onto it and I want to pull that part out a certain distance. So usually, once you wheel your sub spindle over, you grab onto the part, you'd have to do some math here. Let's say I'm pulling it back 6.5 inches. I would obviously have to say 48 inches minus 6.5. Now with incremental spindle moves, I can hit this drop down and say, move an incremental distance for where the spindle currently is, move it 6.5 inches. So that way we don't have to do any math. Takes the guesswork out of it. Another small change, you've never seen Millturn before. This is our job setup page where we can go ahead and tell Mastercam, here's my part, here's where I'm holding on to my part, here's where I'm going to come pick the part off with my sub spindle, so on and so forth. Right now we're in the bar stock page setting up our stock for this part. And what they've done now for 2022 is they've given you this little button here that you can click on that allows you to click either a wireframe or solid arc or simply click on a radial face and it will pull the diameter that you click and put it into your diameter field. Now we've actually always been able to do that, but you have to right click in that field, that yellow field, right click, select diameter of an arc. So now they've kind of taken a couple clicks out of the equation. We've always been able to create a library of 2D inserts, library of 2D holders, and you can block them up to make your tools. Last revision of Mastercam, Mastercam's been pushing these 3D tools ever since they come out, just to kind of make that Millturn simulation that much more accurate. So now what you can do in 2021 is you were able to create as many holders, as many inserts that you wanted, to build a library of that, block them up to make a library of tools. 2022, if you have a use for something like this mini turret here, you can now bring in adapters, you can now bring in hubs, these holder bodies. You can build up an entire library of that as well, and you can build up any sort of mini turret configuration you can think of. Another simple edit here, they made a checkbox for center operations that automatically retracts your center. So currently in this operation, I have my center starting away from my part by 96 inches. I then feed to 0, 0 to engage my center on my part. I have this checkbox here, generate retract operation. And as soon as I hit the green check on this operation, it's automatically going to create a separate operation that G zeros my center back to a Z of 96, wherever it started initially. So what we can do in this operation is if I wanted to, let's say I wanted to engage my center, then do some turning. When I'm done with the turning, I want my center to retract. I could just take this new center operation that it generated for me, slide that down below my machining operations. When my machining's done, my center retracts. We've always been able to do this. You just manually had to create this operation yourself. That checkbox now does it for you. And probably this is definitely the biggest thing for Millturn this year, is now the ability to create and use steady rests. So what I'm actually going to do with you guys here is we're going to go through here and actually build one of those steady rests. We're going to go into the GMD file. I'll give you a crash course on that. Unfortunately, Pat, I don't think you need a crash course on that one, but you're gonna get one. We'll go through that, show you what the GMD file is all about, and we're gonna go ahead and create this together. And I'll be the first to say that sometimes creating locators inside of the GMD file is a bit of a pain. Creating the steady rest, they did a really good job on it. It's super simple to go through a part and create the steady rest. So I'm going to run through that with you guys. When you go into the work support page in your job setup, what this is showing you, it's only going to show the appropriate option here. So if you don't have a lower turret, it's not going to give you the option for a turret mounted steady rest. Or if you don't have a turret in general, it's not going to give you that option, right? So it's going to be machine specific. If you pick a machine that has a lower turret, it will give you that option. If not, you'll just have the ability to use a standalone. If you guys have ever done spindle moves inside of the Millturn or Lathe product, that's exactly how the steady rest moves work. So going back to spindle move here, how that function works, if you've ever used it, is click on that operation. You can tell Mastercam if you want your spindle to clamp or unclamp. Then you can also tell it if you want it to move, go from point A to point B, and you can also open up that toolpath and tell it to close. So open, close, or move. That's the same way the steady rests work. We can use these operations to open the steady rest, move the steady rest onto our part, clamp the steady rest, and then after that we can move it wherever we want as well. So we'll go over that together as well. So let me actually take a quick peek here. We're going to go through the setup of that steady rest. I'll show you how we can go ahead and create it. Before I get there, like I said, I wanted to show you a little bit of the GMD, what it is, how to use it. The GMD file, it can be found on this page. And if you ever use Millturn, I'm sure you've seen this pop up before. Probably gave this no mind, as I usually try to do. But if we ever need to go into our GMD file, it'll say component libraries, and you have an inch and metric version of your GMD. So we can double click on one of these, and it's going to launch in a separate window of Mastercam. So I already did that, and I got it up right here. Okay, so this is the holy grail of all of your files that you have in terms of tool locators, chucks, jaws, steady rests. That all can be created and stored here in the GMD file. So if I take a quick peek, just to show you guys what we're looking at, if I expand my upper tools group, this machine has a B axis. And as I can see, we have all these different HSK style locators for our upper spindle. If I go to my lower tools group, I have these lower tool locators where I have 2 station for cross turning, a face turning station, boring bar stations, so on and so forth. Once again, if you've used the Millturn product, I'm sure you've seen a lot of this. And we also have chucks and jaws. Okay, so let's say you guys always use a specific collet and collet chuck, right? But every time you go in to use Mastercam, it always loads up these chucks. You have to always remove them and replace them with what you want to use. Okay, so this is your default of what Mastercam always loads up with. If you wanted to create these collet chucks or collet jaws, or either whatever, some sort of specific chuck jaw group, you can create those. And then once you create them, you can just drag and drop them into here. So every time you load up your Millturn machine, it loads up with the chucks and the jaws that you want. All right? So what we're going to do now is we're going to create the steady rest. And all I did is you can hit the green check on this page to get out. To get back into it, you can just click on machine definition and you're back into this page. So this GMD file works like a normal file. I can bring bring entities into this if I want, which is exactly what I did with this. I went to File, I went to Merge, and I went ahead and selected all of my SteadyRest components, and I brought them into Mastercam, into my GMD. I also went a step further. I took everything and I broke it out onto their own levels. That's not something you need to do, but I just did it for the sake of organization. So let's go back into the GMD file and actually build this thing. Go click back to machine definition. Go to my lower tools group. Right click on turret, and we're going to build ourselves a SteadyRest. Alright, so I have obviously several components to the SteadyRest. We have 2 arms and a piston, and then we have the body of the SteadyRest itself. I'm going to start by defining some of those smaller components first. I'll start by defining the arms. So I'll click on Add Arm. I'm going to say Set Name from Solid because I actually named that level that the solid's on arm, so it should come in with that same name. That's not super critical, but it's good for organization purposes. Also, set color from solid. If you check that box, whatever color the solid is what it will show in actual simulation. So if you have a reason to make that a specific color, you can make your solid that color, and it will play that way in simulation. You can also change the color right here if you'd like. I'm going to go ahead and select that arm. I'll click this button here to do that. And I'm just going to go ahead and select this arm right here. I then need to select the center of rotation for that arm, which is obviously going to be this point right here. Aside from that, for the first arm here, I just need to tell it how much can this arm actually travel from its open position to its closed position, and then how quickly do I want the actual arms to close. So I'll set a feed rate for that as well. We're going to do the other arm. It's the exact same procedure we just did for the first one. Click Add Arm, select my other arm, select the center of rotation for that arm, and then give it the how much it can close in terms of angle and how quickly it can do that. So the arms are done. Let's do the piston next. I'll click on Add Piston, same thing as before, select my piston. How much can that piston travel from its open position? And how quickly can it move? Okay, so we're all set there. The only thing I have left to do is actually define my turret body itself. Not turret body, I'm sorry, SteadyRest body itself. So this one I don't have on a named level. I'm just going to go here, click my button, click my body. I need to then grab the center point, which I brought this in with a circle here that defined the center of this feature. I just drew that myself, nothing fancy about it, and I obviously have that on a level. So select that center. And then you can either draw an avoidance boundary or you can simply type in the size of the avoidance boundary you want. So, just in terms of collision for the SteadyRest itself, if something comes so close to it, you could define a boundary that you don't want any tool or any other feature of your machine to get within. So I'm just going to type in some random values here, and that's really it. The only thing I really have to do is go to the second page, and since I can't really see it, it takes up 3 positions, this turret mount SteadyRest. So let's say I put it in station number 2. So if it's in station number 2, that means stations 1 and 3 also have to be disabled for me to do that. Okay. I'm going to hit the green check on this. I'm going to hit save. Now the one thing that was going to absolutely screw you guys, and I'm going to show you this because it happened to me several times, is once you make a change to your GMD file, you saw me hit save probably on this other screen before I left it. So if I go back here, I hit save here and it flashed, and to me that means it's saved. But if I go back to my Mastercam right now, it actually didn't save. It's a little bit of an annoying thing for me here. There's a little asterisk next to your GMD file. That means it's not saved. So if you hit save up in the top left-hand corner now, I gotta click on my GMD. Why won't you let me? There we go. Now I get save. And once I hit save, now it's saved. But that little nuance there caused me a little pain and heartache initially. creating a locator about 10 times over again, and then it's gone. I can't figure out why it's not saving. I'm like, I just did it right 10 times in a row. What's going on? I've been there. So let's see if this actually worked though. So if I go back to Mastercam, I have a part already programmed with my steady rests, and let's take a quick look at those steady rest operations to see what's involved with them. Go into the parameters of my first operation, and it is just an unclamp. So I came in here, told my steady rest to open up so I can go ahead and put it somewhere else on model. So now that it's open, I'm going to go ahead and move it onto my piece. So the next operation here are 2 G1 moves that move it onto my piece. And then if I go to my last one in this group, it's a clamp. So I unclamped my steady rest, moved it to where I want to on my part, and clamped it. So now clamped on our part. And the cool thing about this is we're not just doing it for grins here, we're actually doing it in a pick-off cutoff cycle, or just a pick-off cycle, I should say. So what we're actually going to do is once we wheel our steady rest over and we grab onto our part, we're actually going to go ahead and transfer this part to the sub-spindle. In doing so, we're going to go ahead and move the steady rest back along with it. And then we'll do a little bit of machining at the end. Okay. So in that last steady rest operation I'm talking about here is just a G move. G1 move it back to where the sub-spindle is. And the only other aspect of that we have to worry about is we have to sync it correctly. All right, so I'll show you that. I'm going to hit the X on here. And if you guys know Millturn, if I want to go ahead and get this thing into a simulation, or if I want to post code, what you're going to want to do is select all of your operations and click on the button for G1, as if you were trying to post code for lathe or mill. It's going to take a minute and pop up with a second IOF window. Once again, the stuff that we saw before that you probably never really care about, this usually pops up. But it should pop up with my actual, there we go, it's thinking about it. All right. So if you've never seen this before, this is where we can go ahead and sync our operations, play our simulation, post our code, all that good stuff. So let's expand these operations really quick. Let's talk about what's actually happening. Wish I was taller so I could point to this stuff. Yeah, that's not going to work either. So if you guys look here, this is our upper stream, this is our lower stream. So currently, our upper turret, if you look at the very first operation, is the turret park. So our operation number one is going to go ahead and park our turret above the left spindle. That's totally fine. I don't really care what that's doing. If we take a look over here in the lower, you can see we have our first operation is not synced to anything. Second operation is not synced to anything. So initially, as soon as I hit cycle start on this machine, steady rest open, steady rest moves onto my part, and then steady rest clamps. And what we can see here is I've synced this clamp move to the beginning of my transfer cycle. So I'm saying once my steady rest is now clamped on the part, now we can begin our transfer cycle, transferring that part to the sub spindle. And the only other thing I had to sync here was the steady rest when it moves back towards my sub spindle. And now you can see I link this up, is it's point A to point A, right? I said when my spindle moves over here, so does my steady rest. And when it's done moving, so is my steady rest. Okay, so they should move along with each other, and when they're done moving, that should be it. And we should continue on with the rest of our cycle. Let's take a peek. If I hit launch here, watch now, this won't work. There we go. Usually pops up as a separate instance of Mastercam. It's your machine simulation. So I'll look for my Mastercam. There it is. And it's really nice to have the whole machine housing showing. But generally when I'm playing this thing through, I like to turn that off so I can get a better view of what's happening. And let's take a peek. I'm going to slow down this thing a little bit. Where's my... I'm just going to hit play. Slow it down just a touch. So let's watch our steady rest. So what should happen is this upper turret should go park, our steady rest should start doing its thing. Or maybe nothing's going to happen. There we go. So upper turret parks, and while that's happening, Our lower is beginning to get that steady rest into position. It's going to move over an X onto the part, and you'll actually see those arms clamp down. Now that that's happened, our sub spindle is going to wheel over, can grab onto our part. And you guys might see this orange in simulation, not only in Millturn, it's also in Mill. I don't know exactly what's set here, but anytime you see orange, it's a proximity alert. So it's saying, I don't know exactly what it is on this part. Let's say I told Mastercam if my turret gets within 3 inches of my stock, then I want it to throw an alarm. That's what you're seeing. I don't know what it's currently trying to tell me I'm getting too close to. But if you do see that, there's nothing colliding. It's just you're getting too close based on the settings that you have. So it pulls that part back with the steady rest, and once that's done, our tool's going to come over and just do a really simple facing operation. Come on. See how choppy that simulation is, by the way? One thing that I always like to do if I can handle it on my machine is the type of simulation that you use will influence how it actually plays through. So, for example, right now I'm using length mode. And why that looks so choppy is it goes from the endpoint to the endpoint of a tool path. We could do something like time if you really want to check out and get really smooth simulation. Let me see what that looks like. It'll probably look terrible now that I'm talking about it, but we'll see. It's kind of choppy still. This should be a little bit more smooth when it pulls this thing back. Come on. There we go. That's a little bit more smooth than it was before. If you have a hard time with that being choppy, I would make sure you try to slide your performance more down towards performance. That'll allow it to run a little bit faster and it won't show as much precision on your part. But also time mode does usually show it the smoothest as opposed to the other options. All right, but that's steady rests. Once again, they're really, I usually say this, and I've said it to Pat before, the GMD file usually isn't that hard to edit, and I've since regretted saying that because I've had to make a living of working in the GMD file and making locators, and it drives me insane. Steady rests really aren't bad. They're pretty easy to create. They're pretty easy to use. They just need to do a little work on those locators. But let's finish this thing up. I got a couple things for Lathe that I want to talk about really quick. These two things aren't specifically new, but they've got a little bit of TLC in the last year, and I think that's it's pretty important to mention it for these two things. First is custom threading cycle. This came out last year, and it's for obviously machining stuff like rope threads or custom threads like that. When it first came out, it was super cumbersome. Like when you did a toolpath, I thought it should work, and it never, I had bad results with it the first few times I went to use it. It seemed more difficult to use than it needed to be. They've made a lot of updates over the past year on this. So fixed with the updates that come out with Mastercam, it's become much easier to use than it was after the initial release. And we've had a lot of customers use it, and we've had a lot of great success. You know, it's really cool seeing a part that comes out with a thread like that. It's not something you see every day. And the other one's kind of a big one that I've personally been holding off on myself. Solid chaining for lathe. Right? I tell everyone in my mill classes now, if you're making wireframe on your part, you're wasting time. Right now in Mastercam, solid chaining is so powerful. It's just at the same level that wireframe is. So no real use in adding that extra step anymore. So we now have the ability to do solid chaining for lathe. Okay, so I don't have to add it, make a turn profile. It actually creates one for me. So the reason why it's good that none of us actually used this in the past is because by default, when solid chaining was around, it would create a slice profile versus a spin profile. So if you know what the difference is between those two, that's a big no-no that it created a slice, not a spin. Spin will always make sure you have the outermost portions of your model on your profile. When you do spin, it actually, for example, to tell you how it works, when you do a spin profile, it takes this part right here, spins it around 360 degrees, and traces that profile. So it knows exactly, like this would be spun 360 degrees around my part. So I'd actually have this feature on my turn profile so I don't turn it off. Imagine that feature wasn't on the top of my part. and it was on right here. If I do a slice in the top of my part when that feature isn't there, I'm going to get the wrong turn profile for my part. That's why slice isn't necessarily great. So let's go over that really quick. Just going to load up a part, solid chain. And let's go over how to solid chain. It is as easy as it sounds. There's no wireframe on this part, so Mastercam knows I can't chain wireframe. So if I go into a normal lathe finish toolpath, it automatically switches me to this view, and you'll notice up here I'm automatically switched to select solid. Okay, so this is your solid chaining options. It's not any more difficult to select the normal wireframe. If I click here and I click here, my part's chained, I can hit the green check, and I'm all done. Right? So I've said it for lathe for a couple years now, or for mill rather, that you don't need to create wireframe. You're adding an extra step for yourself. Now for lathe, that same thing is true. We can use our solid chaining. It works just as good as our wireframe chaining. But really, I know that was a bit of an abridged lathe and Millturn version. Not a whole lot new this year.